This is a two-parter because it won't let me record one full thing. But anyways, we left off at percent equation, right? So the whole point of the percent equation is what do we know, what we don't know, and we kind of put it into this formula and we solve for our missing value, right? Um, all right, so now we're going to talk about the real number line, right? So now the real number or real numbers. All right, let's begin with talking about what makes our number system, right? So we have natural numbers, which we kind of spoke about in class. Natural numbers are also known as the counting numbers. So that includes one, two, three, four, and beyond, right? So any positive whole number, right, is there. I mean, any positive number, right? Whole numbers are totally different though. Whole numbers are just like natural numbers, except it includes zero. So difference between natural numbers and whole numbers, natural numbers does not include zero. Whole numbers does include the zero. So we have 0, 1, 2, 3, 4. Then we have integers. It's denoted by z, right? Integers includes negative and positive numbers. So it includes all the numbers that are negative, right? So negative 100 all the way to negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on to infinity. Rational numbers. So this is where it actually gets, or the most important part, right? So rational numbers denoted by q. Rational numbers include fractions, right? So n over m. We know that fractions cannot have a denominator equal to 0. So here our denominator is m. So m cannot be 0. This includes numbers that can be written as fraction, decimals that terminate, meaning that they end, and decimals that repeat but have a pattern, right? So the opposite of a rational number would be irrational. Irrational are numbers that are not rational, right? They are decimals that are non-repeating or never-ending, and a famous irrational number is pi, because pi is 3.1416, but that decimal keeps going on forever and ever, and it never stops, and it doesn't have a pattern. So that's why pi goes on forever and never stops. There's no pattern to it, and that's why we say it is irrational. We have the square root of 2, which is also irrational, because you plug it in, it's going to give you a long number, a long decimal, and it'll never end, never stop. So big differences, right? Rational numbers are numbers that you could turn into a fraction, and if they are decimals, they end or they stop at a certain point. And if they do repeat and they go on forever, it's a pattern, right? So like, let's say we have, uh, share my screen. So let's say we have the following. Sorry, let's share this right now. All right, let's say we have the following. So let's say we have a decimal who is 0.4343, and it keeps repeating. Although it will never stop, right? Since the pattern is 4343, it is still rational. Sorry, that R looks kind of messed up. Rational. All right. However, pi is one of those things where it's 3.1416. I don't know the rest of the numbers, but it goes on forever and there's no pattern to it. So rational numbers that do go on forever either has to be a pattern. If it's not a pattern, then it's irrational. Or numbers that, let's say, they just go on forever, like not go on forever, but they kind of go, but then they stop at a certain point. So this one would stop here. So it's still rational. Okay. Um, let's go back to the next portion. Uh, sharing this. Let's move back to our PowerPoint. All right, now our PowerPoint. So that's basically it, right? We have natural numbers, then we have whole numbers, integers, rational, irrational. If we were to draw a little tree or a little diagram, right? Given n, we know that it's either rational or irrational, but it cannot be both. So the set of all rational and irrational numbers makes up the real numbers, or R. So notice how we have the natural, the wholes, the integers, the rationals. Irrationals are not included into any of these, and that's what makes up real numbers. Adding and subtracting real numbers. When adding and subtracting real numbers, there are two cases we consider. Case one is adding and subtracting numbers with the same sign. And then case two, adding and subtracting numbers with different signs, right? So an example, 15 plus 32, they're the same sign. We just add normally. What is 15 plus 32? 47, right? Let's look at -12 plus -7. I think somebody mentioned this in class, and yes, it's the same thing as saying this. So let's look at the other tablet. Oh, not this. So let's look at example this one. -12 plus -7 is the same thing as saying -12 minus 7, right? But since we're talking about addition, right? When we're adding two numbers that are the same, kind of do it and we keep the sign. So 12 plus 7 is 19, all right? But since it's a negative, we keep the sign as a negative. Right? The way I explained it in class was if I asked you for $12 and then I asked you for $7 again, I owe you 19. So I'm at a negative. I'm in debt. I owe you 19 bucks. Um, let's look at what else? Let's look at this same thing. -30 plus -8, right? We're going to add the two and then keep the sign, right? Or it could also be written as -30 minus 8, right? Add them and then we keep the same sign. So if I ask for 30 bucks and then I ask for $8 again, I owe you a sum total of $38. So I'm at a negative. I owe you 38 bucks. All right. On the other hand, some of the more or what we've always been doing since we were little is if we have something like 4 plus 26. Same sign, we add it and we keep the sign, right? 4 plus 26 is 30. They're both positive, so we keep positive. Let's go to the next portion. Trying to speed run this because apparently you could only record for a certain amount. Okay, so that's the case one, right? Add the numbers with the same sign, right? We add the numbers together and then keep the sign the same, right? So here we did 15 plus 32. Here we did 12 plus 7. We kept the negative. 30 plus 8 is 38, and we kept the negative. 4 plus 26 is 30 as well. Well, a lot of 30s today. And we keep the sign. All right, case two, adding numbers with different signs, right? My bad, a typo. We find the difference first. So we're going to subtract both numbers, and then we keep the sign of the bigger number. So here we have 23 and -73, right? It's the same thing as saying 23 minus 73. We're going to subtract these two numbers and then get the sign or keep the sign with the larger number. So here, what's the larger number, 23 or 73? 73 is the larger number. So uh, our end goal is going to be a negative. So let's look back at examples. Uh, right, so we have 23 plus -73, right? It's the same thing as saying 23 minus 73. So what are we going to do is we're going to find the difference, right? Or minus both of these numbers. So what is 73 minus 23? Get 50, right? 73 minus 23. 3 minus 3 is 0. 7 minus 2 is 5. 5. But what is the larger number? Well, it's not 23, so it's not going to be a positive. It's 73. And notice how there's that negative sign in front of it. So we're going to have -50. Okay. Let's look at another example. I'm trying to take pictures of the thing. And we have, let's look at -23 plus 15, right? We're going to find the difference. So what is 23 minus 15? Right? 23 minus 15 gives us 8, right? But we keep the sign with the larger number, right? 23 is the larger number. So since there's a negative in front of it, this is going to be -8, right? Another way to look at this is also if I owed you 23 bucks, right? So I'm at a negative, I'm -23, right? But then I finally have some money to pay you off and I give you 15 bucks. I still owe you money, right? And that's why I'm still at a -8. So I asked to borrow $23, so I'm at a negative. I paid you back 15 bucks, and now I still owe you $8. So that's why I'm at a negative. So hopefully some of these questions are not so strange. We'll do another one, negative 63 plus 42, right? 63 minus 42. When we subtract that, right, we get 21, right? And then which one is bigger, 63 or 42? Well, 63 is larger, so we're going to keep that negative sign. And basically, that's how it usually goes. You are allowed to use a calculator, so if you're not as good doing, addition or multiplication or subtraction, uh, you could always use a calculator. Just be very wise with it. Make sure you punch in the numbers correctly. Now let me go share my next screen. Okay, so we have special cases. Whenever we have a subtraction sign close to a negative, we actually combine them both and it becomes an addition, right? So we have 110 minus negative 14. Since that minus and since that negative are very close to each other, we kind of group them together and it becomes an addition. So now it becomes 110 plus 14, which is 124. Same thing here. Let's look at this portion right here, right? Notice how we have a negative and a subtraction sign close to each other. Let me screen record my other thing. All right. All right. We group these together. This becomes an addition sign, right? And now we have negative 13 plus 5. Now we know how to do this, right? When we're adding two numbers that are not the same sign, we have to subtract, right? What is 13 subtracted by 5? That is 8. And keep the sign with the larger number. Well, it's negative 13, right? So 13 is a larger number between itself and 5. So we keep that negative, right? On the other example that we saw, it was 110 minus negative 14. Notice how those two negatives are too close to each other. The minus and the negative, this becomes a plus. It becomes 110 plus 14, and that is 124. That's your final answer. So these are your special cases, right? When you see them too close to each other like this or like that, make sure it becomes an addition sign, and you know how to do the rest. We follow along like we've been doing for the previous ones. All right. Uh, let's look at the next one. Adding and subtracting real numbers, right? When adding and subtracting decimals, we have to line up the decimal point and add and subtract as per usual. So we will look at that as well. A lot of this could also be done on the calculator. You don't have to do it by hand, but if you don't have a calculator, it's still possible to do it by hand. So I'm just going to copy some of the questions over here. So then we don't have to waste any time. But yeah, it kind of follows the same rules. Same rules apply when we're doing with positive and negative. All right, so let me go share my other screen. All right, so notice how I lined up the decimal points. Notice how I lined up the decimal points. This is on a decimal point. That's my decimal point. They're right on top of each other. Let me just add another zero here. So it's 12.50 and 5.78. I could add that zero because it's missing. And now we just add. What is 0 plus 8? It is 8. What is 5 plus 7? That's 12. And then we do 5 plus 2 plus 1 is 8. And then we bring down that 1, right? This decimal point stays in its position. So now we have 18.28. Let's look at the other side, right? What is 5 plus 6? We lined up our decimal points, right? And then we just add regularly. 5 plus 6 is 11. Bring that 1 to the top. What is 4 plus 1 plus 7? Well, that is 12. What is 1 plus 0 plus 3 is 4. And then we bring down that 1. This decimal stays the same, and we get 14.21. Let's look at another example when it's not so obvious. So one of the examples on the other sheet was 3 3.56 minus 8.12, right? Other way we could look at it is saying 3.56 plus negative 812, right? And so what we do, we find the difference and then we keep the sign with the larger number. So let's find the difference first. What is 8.12 minus 3.56, right? How we've been doing it for our lives. We can't do 2 minus 6, right? So we have to borrow. What is 12 minus 6? Well, that's 6. You can't do 0 minus 5, so we have to borrow from the 8. This becomes 7. That becomes a 10. 10 minus 5 is 5. We bring down that still decimal point. It stays the same. And what is 7 minus 3? That is 4, right? So our answer is 4.56. But just like adding and subtracting real numbers, right? What happens when we add two numbers that are different signs? Well, this sign, we keep the sign with the bigger number. So notice how 8.12 is bigger than 3.56. So this becomes a negative. So our answer is negative 4.56. Another way to look at it, I guess, is if you have something that's 3.56 and I'm going to get a loss of 812, I'm going to lose more money and I'm going to have to owe. So that's why it's negative 4.56. Okay, and so that's basically what we do here. Let's look at the following. Multiplying or dividing real numbers, right? There's two cases. Whenever we multiply or divide by real numbers, if the signs are the same, then it will always be positive. So negative 3 times negative 2 is 6. So because it's a negative times a negative, it's always going to be positive. 30 divided by 3 is equal to 10, right? And it's going to be positive because the signs are the same. Here, though, negative 12 divided by 3 is going to be 4, right? But since they're different signs, it's going to be a negative. So this one's, I guess, easier to grasp, right? If we're multiplying or dividing by the same sign, it's always going to be positive. We do the application and it becomes a positive. But if we're multiplying and dividing by numbers with different signs, we do our arithmetic, right? Our multiplication or division, but the sign just becomes negative. Continuation of this is when we're multiplying with decimals, we multiply regularly, except we have to take into account how many decimal points we have. So we could count the decimal places, and that's how we determine the overall position of it, right? So notice how here we're doing 3.25 times 0.1. We multiplied regularly. 1 times 5 is 5. 1 times 2 is 2. 1 times 3 is 3. Here we count, though. 1, 2, 3. There's 3 decimal positions, so that means on my bottom part, I gotta go 1, 2, 3. It becomes 0.325. Let's try some examples. Let's stop sharing here. All right. Great. We're right on the thing. So let's do 3.6 times 4.2, right? We multiply regularly. What's 2 times 6? It's 12, right? 2 times 3 is 6 plus 1 is 7. Write down to 0. 4 times 6 is 24. So we write a 2 on the top. 4. 4 times 3 is 12 plus 2 is 14. We add 2 plus 0 is 2. 7 plus 4 is 11. 4 plus 1 is 5. And then we have our 1. Let's count how many spaces we had. We had 1 space, 2 spaces. That means from here, you go 1, 2. And our overall answer is 15.12. Okay. Let's look at another one. 12.3 times 2.5. Multiply regularly. 5 times 3 is 15. 5 times 2 is 10, plus 1 is 11. 5 times 1 is 5, plus 1 is 6. We draw a 0 at the bottom. Well, I don't know if I have enough space. What is 2 times 3? That's 6. What is 2 times 2 is 4. And then 2 times 1 is 2. We add all of it together, and I'll kind of write it up here. 615 plus 2, 4, 6, 0. 5 plus 0 is 5. 6 plus 1 is 7. 6 plus 4 is 10. 2 plus 1 is 3. But how many spaces do we have? We have 1 space, 2 space. So we go 1, 2. At the end of the day, we have 30.75 as our final answer. 30.75. Okay. Division is kind of the same. Nah, I wouldn't say same thing. Division is kind of like a different way of doing it. So let's say we have 0.2 and we're going to divide it by 8.40. What we have to do is we have to turn this one into a whole number. So we move the decimal spot by 1, and now it's going to become 2, right? But if we did that for this number, we also have to do it for this. So we change it. So now this becomes 84.0. How many times can 2 go into 84? Well, lucky for us, it's a whole number. It's going to be 42. 42 times 2 is 84, right? And the decimal spot stays up here, but it's perfect because 84 minus 84 is 0. We don't have to do anything, and it stays like that. But let's look at another example where it does not stay like this. So let's look at 2.5 divided by 4.25. How do I make this into a whole number? I got to move this decimal spot by 1 more space, and this becomes 25. All right, but since I did it for that number, I have to do it for the number inside of the house. So we move it by only 1 space. If I moved it once, I got to move it once here. So now this becomes 42.5. How many times can 25 go into 42? Well, I realized that only 1 time could go. So now it becomes 1 times 25, and that is 25. Subtract it, and we get 17, right? I keep my decimal spot, and I bring down the 5. How many times can 25 go into 175? Well, it could go 7 times. And now my answer is going to be 1.7. And the rules of multiplication and division stay the same, right? Let's say if this was a negative, since they're 2 different signs, then at the end it's still going to be a negative, right? For example. But in this case, that's how we divide real numbers. Okay, like I said, calculator will do this for you very simply, very simple. So no stress if you don't remember how to do this or you're still rusty on it. As long as you know what it's asking for, that is the main point. All right, we just went over this. Now we're looking at examples. We did these examples as too. I don't think we did this one, but it's fine. Remember, properties of real numbers. So the properties of real numbers, right? We have the commutative, means that a plus b is equal to b plus a. That's for addition. For multiplication, it's a times b is equal to b times a. Associativity property, a plus parentheses b plus c is the same thing as doing a plus b plus c. So if I add b plus c first, it would be the same thing as if I did a plus b first and then I added the c. Distribution, all right? If I have a times b plus c, I just distribute inside of the parentheses and I become ab plus ac. Identity, right? If I have any number plus 0 is always going to give me that number back, right? For multiplication, though, it's different, right? If I have a number and I multiply by 1, I'm going to get that number back. Inverse is just basically telling me what do I have to add in order to get 0 back? And well, that is a, or any number, plus its negative counterpart is always going to give me back 0. For multiplication, it's kind of different. I have to do the reciprocal, or its flipped version, right? I have a, let's say 2. I would have to multiply by 1 over 2 in order to get 1 back. These properties are You've seen it all throughout like elementary school and middle school, and they're nice. They kind of work later throughout the whole year when we deal with harder problems. But that's basically what it means. You've seen this and you've used this all your life, right? We have a plus b, and we have 2 plus 4. 2 plus 4 is 6. Is it different or any different from if we do 4 plus 2? No, we're just flipping the numbers, and it should give us the same thing. Same thing as multiplication. 2 times 3 is 6, but 3 times 2 is still 6. So that's the nice thing about it. Order of operations, right? Order of operations just tells us how we do the math. So first thing you want to do is parentheses. Parentheses come first, then exponents, then multiplication, then division, then subtract, then addition, sorry, and then a subtraction. And we have to follow this order. All right, so let's work with this real quick. Let me stop share. Oh, let me take a picture of this so then I'm not going back and forth. All right, so let me stop sharing and let me share this. All right, so real quick, the properties of, you know, addition and multiplication. It won't be on the quiz or anything, but it's just nice to know, right? Right, like I said, 2 plus 5 and 5 plus 2. It's going to be the same thing, right? 2 plus 5 is 7. But then if I do 5 plus 2 first, it's still going to be 7. For multiplication, I've had 2 times 3 and 3 times 2. It's still going to give me back the same product, right? 2 times 3 is 6. But if I do 3 times 2 first, it's still going to give me 6. The main one that you will probably always have to remember is distribution, right? That's A parentheses B plus C. Kind of distribute inside. And we'll see that when we deal with terms or expressions. And that basically becomes AB plus AC. But in the meantime, just have that in the back of your mind. And let's deal with this. So we have 8 divided by 2 plus 8 minus 3 to the power of 2. So we know PEMDAS, right? We know PEMDAS. It says parentheses first. So we're going to focus on parentheses first. Where are the parentheses? Oh, parentheses is right here. So we do whatever whatever is inside the parentheses, which is 8 minus 3. What is 8 minus 3? That gives us 5. So 5. We bring down everything else. All right. And then what's after parentheses? Exponents. Do we have an exponent? Yes, we do. We have 5 to the power of 2. What is 5 to the power of 2? Well, 5 times 5 is 25. Notice, this is not the same thing as saying 5 times 2. A lot of people get confused, but that's not what we're saying. We're saying we're taking 5 and we're multiplying by itself 2 times. So it's 5 times 5. All right, not 5 times 2. That is a common misconception that a lot of people sometimes make. We're not doing this. We are doing instead this portion right here. 5 times 5, 25, plus 2 divided by 8. What's after PEMDAS? Multiplication. There's no multiplication to be done, so we could do division. Let's see if there is division. Yep, there's division occurring right here. What is 8 divided by 2? Well, that is 4. Bring down everything else. All right, we did division. Is there addition? Yes, there is. What is 25 plus 4? And that is 29. All right. Let's see our next portion, our next example. If you do this on the calculator, though, be very careful that you use parentheses because if you don't use parentheses, it will give you a totally different answer. And you don't want that. So the use of parentheses is very important. Let's do the other question. It's 4 times 2, parentheses, 6 minus 2 to the power of 3 PEMDAS. Right? We have parentheses first. What is 6 minus 2? And that is 4 to the power of 3, 2. All right. So parentheses check. Do we still have exponents? Yes, we do. What is 4 to the power of 3? Gotcha. 4 to the power of 3 is 64. So now we have this. We have 4 times 2. And then whenever 2 is close to a number like this, it really just means that we're multiplying. So we have 4 times 2 times 64. We're up to multiplication. So that means we could just multiply across. So we could do 4 times 2, right? Which is 8. And then 8 times 64, which will give us 64 will give us 512. And that's how we go about it. This will be on the little what is it called? Diagnostic exam. Um, but there's a lot of practice problems on, you know, Lumen. So be sure you use it, please. We only have 9 minutes left for this recording. Okay, expressions. A term is a single expression, such as 2, 4x, -3, x to the power of 2, and so on. So terms are just things like this, right? It could be a constant, it could be a variable, it could be an exponent. So expressions, though, expressions are statements involving at least two terms. So for example, these are expressions: 3x plus 14 minus 1/2, 2x squared plus 13 plus 2/4 plus 13x. All examples of expressions because it involves more than two, or at least two um, terms separated by an operator, right? An operator is just a fancy way of saying your multiplication, division, addition, or subtraction signs. Constants are fixed quantities that do not vary. Typo again here. Sorry, but they do not vary, right? So a number. A number does not change in this case, right? It stays the same unless we're adding things together to it, but that's what a constant is. Then we have a variable, right? And a varying quantity represented by a symbol. Most notably in math, we use x. That is a variable. That means that we could decide what we want x to be, whereas a constant just stays put. Coefficient is the numerical part of a term. So the coefficient is usually the number that you see in front of the variable. So here we have 4x and the coefficient is 4. So in this example, the coefficient of x squared, which is this portion right here, is 2. The coefficient for x is 13. For the coefficient here, right, it's 3. 3 is the coefficient of x. It's the number that is attached to that variable. All right, you can only combine like terms, right, only if they are alike. So notice out here, 3x plus 4. They are not alike, and you cannot combine them because one has an x and one has 4. So we cannot do that. However, if we have an example like 12x plus 5x, we can do it here. Why? Well, because 12 has an x, 5 has an x. So when we combine them, we keep the same variable, but we just add the coefficients. So the coefficient here is 12, and here's 5. So all we have to do is 12 plus 5, and that is 17. So this becomes 17x. But it's better to do examples, and we will do examples right here. Let me stop sharing. Six minutes left. Great. Okay, so one of the examples is -6k plus 7k, right? They both have k, so that means I can combine them. So the variable stays the same, so I'm going to stay with k, but we just add or do the operation of the coefficients. So here we have -6 plus 7. We know that when we're adding two different signs, we subtract and we keep the sign of the large number. So what is 7 minus 6? Well, it's 1, right? And then what is the one with the larger what's the number with the larger sign? Well, 7 is the larger number, so it becomes +1. So at the end of the day, this is just going to be 1k, or we could just write it as k. We don't have to write 1, but we could do 1k or just k. Next one, we have n minus 10 plus 9n minus 3. So a common rule is always circle or highlight what terms are the same. So here I have an n, here we have a 9n, and then in a different color and a different way of writing, I could say, well, then I have a -10 and I have a -3. So those are my like terms. These have an n, these are constants. So when I go to add or multiply, right? We do this. What is n plus 9? Well, there's always an imaginary 1 in front of a variable. So what is 1 plus 9? 10. So I could say it's 10n. And what is -10 plus -3? What is -10 plus -3 or you can just write what is negative 10 minus 3. I ask you for, or I owe you $10 and I ask for $3 more. At the end of the day, I owe you 13, or I'm in debt. So that's what we get. 10n minus 13. Look at another equation or another expression. Negative 2x plus 11 plus 6x, right? These are my like terms because they have an x. This one is by itself. There's no other coefficient. I mean, another constant. So it's, we just leave it as it is. But what is negative 2 plus 6? Well, we know when we're adding two numbers that are different signs, we find a difference. So what is 6 minus 2? Well, that is 4. And we keep the sign of the larger number. In this case, it's 6. So it's going to be positive 4. So negative 2x plus 6x is going to be 4x. 11 has nothing to combine, so we just bring it down. All right. Last but not least, we have 12r plus 5 plus 3r minus 5. Well, 12r and 3r, they both share an r. 5 or positive 5 and negative 5 are my constants, so I could combine those. What is 12 plus 3r? 12 plus 3 is 15r. And what is 5 plus a negative 5? So we find the difference. 5 minus 5 is 0. And there's no sign because it's just 0, so plus 0. Or just 15r. And that's basically how we combine like terms, and they'll be very useful in the future topics. All right, so that's what it is. Evaluating an expression. So sometimes we're given a value for our variable. For example, let's say we have the expression 3x plus 16. If we are told to evaluate the expression when x is equal to 4, that basically just means that they want us to plug in 4 into every x that we see. So in this case, if it's 3x plus 16, and they want us to evaluate when x is equal to 4, we plug in 4 into every x we see, so it becomes 3 times 4 plus 16. Here are some examples. Let me just make sure I don't have, or have enough time. Don't think I'll have enough time, but we'll start right when x is equal to 13. I'm gonna have to send 3 videos, but at least that would be pretty helpful, hopefully. We have around 2 minutes left. That should be enough to get this last portion, and then the ending is almost there. So it's telling us to evaluate, right? So we have 3z, sorry. 3z, I wrote it wrong. It's 3 parentheses z plus 8. And they're telling us, well, evaluate it when z is equal to 13. So that means I just plug in 13 into it. Every z that I see. Here, there's only one z, so I'm going to do 13 plus 8, right? What is 13 plus 8? Well, that gives us 21, right? 3 times 21 will give us 63. And boom, that is one of our evaluation. One of the more trickier ones, or the ones that look kind of weird, is the one that you'll see kind of on the practice exam, right? Don't get too scared. All we're really doing is just plugging in those numbers. So let's say we have a is equal to 2, b is equal to 4, and c is equal to negative 3, and d is equal to 1. We just plug it into the equation. So let me stop recording this because it's not going to let me, and I'll pick it up on the next video.